Okay, cool. Well, we are officially two past the hour, so I'm going to go ahead and kick this off, and then folks can join as they're able. But I just want to welcome everybody to today's webinar, monitoring. I'm just going to say how to monitor models in production with Label Studio, which is, I think, a really cool topic. Definitely addresses, a serious issue that a lot of people have, and provides an interesting way of leveraging Label Studio to ensure that your model continues to perform well in production. So I'm really looking forward to hearing this webinar today. A couple of quick announcements before we really jump into things. The first one of which is that we are recording this webinar. It will be made available after the webinar. We'll email a copy to you along with some other resources that get mentioned in the webinar and the tutorial. So stay tuned for that. Also, we are going to have some time at the end for some Q&A. So as we're going along, if you have questions or things that you want to dig into a little bit, feel free. There's a Q&A widget in the little toolbar for Zoom. Feel free to drop your question in there ideally, but we are also monitoring chat, so you can drop it in there as well. But yeah, please give us your questions. We would love to be able to answer them. And yeah, that's kind of it for announcements. So with that, I'll quickly introduce our speakers. So today we'll be hearing from Alec Harris, who is one of our expert product managers here at Human Signal, who's really familiar with this process, this methodology, and Micaela Kaplan, who is our ML evangelist and just an expert at this kind of stuff. So it should be really great. And with that, I'm going to go ahead and turn the time over to Alec. We'll kick things off. Thanks so much.
Thanks, Nate. Like Nate said, I'm Alec. I'm a product manager here. Excited to talk to y'all today. I'm going to set the stage for about 10 minutes and then really kind of give the spotlight over to Micaela, who's going to run through a tutorial here. So just to set the stage, like the scenario we're talking about, one that hopefully you are familiar with, and then kind of, setting the ground for the problem that we see across our user base. So the good news is, like, you and your team have put in countless hours of hard work. You've done your exploratory data analysis, you've done your labeling, you've picked your model architecture, you've evaluated it, and you've deployed it to production. You've thrown a little party for yourself. You've got some positive feedback coming in. So that's all great, celebration worthy for sure. But the problem is that, well, multifaceted, right? Production is always going to be different than you expect. You can't perfectly represent, production in your lab. And the world is constantly changing. So it would be nice to live in a vacuum where your model works perfectly and always, and you can just kind of rest easy, but that's not the case. And we've seen this for a while in traditional ML, where your user inputs can change pretty rapidly. They can drift over time. Things like, if you're using, text models, new vocabulary gets introduced, world events change, and that changes user behavior. And there's also adversarial contexts. So think about spamming contexts, where you kind of have a mini arms race where one team is trying to prevent spam, and then, you have bad actors trying to spam others. So there's kind of always this cat and mouse game that's going on. So this problem has existed for a while in traditional ML. But this problem and kind of one of the reasons why we wanted to kind of surface it today is that this problem actually kind of gets multiplied. It gets amplified in the GenAI space. So before, you had these user inputs that can change and drift and be chaotic over time, and they're kind of unpredictable. That's still true. But now in the GenAI world, you have that on the output side as well, where your outputs are constantly changing. So LLMs are non-deterministic. You have things like temperature, which sometimes, you may want to crank up the creativity or kind of the distribution of your outputs. So you're kind of, opting into that hard problem to solve. We have, known problems like hallucinations. And then even if you kind of try to reduce this problem by grounding, something like an LLM to a corpus of knowledge using a RAG architecture, that's helpful and can give you some peace of mind, but your corpus of knowledge is always evolving as well. So, like, internally, we have a chatbot that at least I use daily, and it helps us answer questions about how our code operates and how our kind of internal docs operate. But those docs are always updating, and so we have this problem as well, where even though we have our LLM grounded to a corpus of knowledge, this is still a problem for us too that we solve in a similar way, because our corpus is changing. We're always updating our docs. We're always updating our code. So then the big question is, like, given these problems, how do you have confidence that that production model that you just shipped, that you spent hours of time on and feel really good about, how do you make sure over time you still have confidence, that you still know that there's that high quality bar? And especially, a lot of the teams that use our product are building this mission critical AI, the models that their business runs off of and that their users depend on. So we've heard solutions across the board. There's kind of no shade here. Like, you got to solve the answers to or the problems to the extent that you can. But we see kind of a spectrum, and it's kind of worth putting them all on the table and then picking the ones that are best. And then we also obviously want to suggest one that we think is good. So the kind of most low level one is wait to hear from your users. Couple of problems with this: it's very reactive. It can be bad for your brand. It's not very scalable. You don't really necessarily get a sense of trends, but if you have a model that's not performing well and you hear from your clients, that never really feels good. We've heard the canonical vibe check, and this happens with arbitrary size and cadence. So basically, it's like I hand select some production level inferences, and I put them into a spreadsheet. There's often painful wrangling, versioning, different people doing different spreadsheets. How do we do the high quality evaluation? It can be unreliable because it just kind of depends on somebody remembering to do it. But it can work at like a small scale and for a short amount of time. And then on the more advanced side, there's tooling to detect drift and distribution changes. More in the Gen AI space, we have LLM evaluation metrics like Ragus. We have LLM as a judge or jury. And we're actually like fans of these things. They're powerful tools here. And actually, like, as a product manager, I'm always hungry to like think about integrations in this space and kind of have our eyes on companies that we think do this really well. Some are experimental, like especially in the LLM space. Some are going to be expensive. And then also, like, a big point here is that we believe that you can't really ever fully replace the human in the loop. So what we're proposing here today is a systematic yet flexible way to monitor your production models to help you solve that big problem while maintaining that human in the loop ethos. So it's built into the name of our company. It's built into our brand. Like, we believe that humans are the kind of center of the powerful AI here. And we believe you can't really ever replace humans. And one of the big reasons for this is, as LLMs get more and more powerful and more generalized in knowledge, we really want to make sure that what they're doing is actually aligned with our interests and actually aligned with your users' interests. And the best way to do that is via engaging with this human in the loop ethos. And then also we want to make sure that we kind of lay the groundwork and then still kind of maintain that the Label Studio ethos of being able to customize, being very flexible, and being able to enhance over time. And just to kind of paint the picture of what Micaela is going to be walking through, this is kind of our very simplified flow chart, and what this new offering provides. So we have a pretty simple flow chart here. You start with your model deployment. So this is kind of the first slide I had here. You've worked hours, you've deployed it into production. Everything you see in green here is more or less what Micaela is going to go through, and this kind of holistic flow is what we see from our users. So first you deploy your model, and then you want to sample your production inferences for evaluation. You want to take a representative sample or maybe a specific sample to kind of do some investigation. You want to evaluate and correct those production samples. That happens within Label Studio. There's various ways to automate, using our existing tooling. Obviously, human supervision is one of the big points here. Once you complete that, you review your metrics against a threshold. And then you ask, the very important question, does this pass my quality threshold? And that's very much a business-driven, user-driven metric. If it's yes, great, rest easy. You actually have answered that big question. How you have confidence? Well, you run through this process, and if it passes your metrics, then you're all good. If it doesn't, then you actually kind of kick off this second part of the flow, which is now I want to probably kick off a retraining or a fine-tuning process. The good news is you've gotten a head start on your labeling, right? You've already done this evaluation. You have a good set of things to start with from a retraining or fine-tuning exercise. It's probably not the end all be all. You're probably going to want to augment and analyze augment your data, add more to your retraining and fine-tuning set. Then you can label that. You can label Studio, as many of you are probably familiar with, but this is kind of the bread and butter of our product. And then you kind of kick off a model retraining and fine-tuning, which then brings us back to the end, which is also the start here. And the TLDR here for what we're proposing is that you can find your problems before your users do. You keep a pulse on your production models, and you have that peace of mind, right? So you can answer that big question of, given the changing user inputs, given the changing outputs of LLMs, given the crazy world we live in, how do you have confidence? And this flow is a good way to do that. So that's the lay of the land. I'm going to pass this over to Micaela to kind of run through a tutorial here. But looking forward to seeing the tutorial.
Thanks, Alec. And before I get going here, I see that there's a hand raised. If you could throw your question into the Q&A section at the bottom, it's in your toolbar, or into the chat. That way we can get to it during the Q&A section. That would be awesome. So I'm going to go ahead and share my screen now. Hopefully we don't get too much imposing demos here. Is that looking good, Nate, Alec? Perfect.
Yep.
So the first thing that you're going to want to do here is navigate to our Label Studio examples repository on GitHub. You'll need to clone it in order to work with this code. You'll clone it the same way you clone any other package in GitHub by clicking this green code button and copying and cloning in your terminal. We'll be working in this model monitoring package that you can find at the top here. Just to give sort of a lay of the land here before I get going, I'm going to dig into this code both in GitHub and in my personal code editor, and really walk you through how you're going to need to go ahead and edit this code to make it work for your system. We tried not to be too prescriptive about what your system might look like, where your logs might be. And so while we built you out a very clean template and it's very usable and it should be a great starting point, we don't expect it to work for every single use case. So we're going to start by looking at the config file. That's kind of our jumping off point. Then we'll go into the scrape logs.py logic, which is the next thing you'll want to edit. And then we'll take a look at how the whole pipeline flows together in monitor project with label studio.py. And during that, we'll take a quick detour into our utils.py file. So with that, we'll start with this config.ini file. It looks just like every other config.ini file you've looked at. This is where we're going to store all of our variables and custom credentials that we need. That way they're only in one place and we don't have to worry about leaking permissions. I'm showing this to you in GitHub because mine is already filled out for the demo system, and I don't want to share confidential information with all of you and the whole of the internet because I would get into a lot of trouble if I did that. But just to give you kind of a quick overview of what we're looking at here, this top section is all of your Label Studio config information, where your Label Studio instance is hosted, your API key. And then here we're going to look at both. You need to put one or the other of these options, but you do not need to put both. You can either provide the ID of an existing Label Studio project, probably the one that you labeled your training data in the first place. And we'll go ahead and we'll take the config file for that and use it in your new project. Or you can provide a custom labeling config by just typing out the string that you would want here. This data section holds the information of the data. Total to extract is how many samples you want in your labeling interface or in your labeling project. Here for demo purposes, we're going to use 4. Our demo data has 5, so 4 makes sure our sampling logic works correctly. Sample by date is the one sampling metric we've looked at already that I will go through later. This log section is where you're going to put in all your credentials for accessing wherever your logs are stored. In our case, it's an S3 bucket. So we'll provide our S3 username, our API key, and the bucket name. If you're using GCP or another system, you'll want to provide those credentials here. And finally, we have this configured to send an optional email notification to you when the project is ready. That way you can truly set it and forget it after you set up your cron job. If you want to provide that information, you'll provide it here. It's set up for Gmail, so if you're using a Gmail server, that's already configured for you. If not, you'll need to go ahead and find what the SMTP server and SMTP port are for your particular system. So with all of that, we're going to switch over to my code editor here, and we're going to look at the scrapelogs.py file. So the scrapelogs.py file is the next thing that you're going to, after you fill out all your credentials in the config.ini, you're going to want to go to this file and work on your scraping logic. Just for demo purposes here, I asked ChatGPT to come up with 5 sample logs for us. So as you can see here, we're working on like an LLM question answering data set. And you can see that our fake generated logs have a timestamp, a request ID, the user input, the model response, and then some other metrics about like the model version and the model server, all things that you might expect to see in standard production logs. We understand that your standard production logs are going to look different than ours do. So I'll show you where to change that logic. So the main function of scrape.py is the scrapelogs.py is the scrape function. The first thing it does is it sets a week's worth of data. If you want to change the cadence of this, you'll change it here. Then we connect to our S3 bucket. Again, if you're not using S3, change the connection logic there. And then we parse through all of the files in the bucket to look for the files that we need. So in our case, we're using that test QA logs _month:day:year.txt file. So we'll go ahead, we'll look for the right file, we'll make sure the date is within our start and end times, and then we'll go ahead and we'll scrape the data. This scrape file method down here, starting in line 44, is where you're going to put all of that logic. So again, this is very dependent on what your logs look like. In our case, this is just some very simple processing for every line in the body. If a certain keyword is in the line, we add it to a dictionary. The output of this function is a list of dictionaries, where each dictionary corresponds to one task in Label Studio. So every task in Label Studio is going to be an example from your logs, which is why we're doing it this way. We then append the dictionaries and we can return a list of all your dictionaries. And finally, we're going to subset our data. So if you go to the subset method, which is down here, starting in line 83, the first thing we say is that if the length of all of your data that you've collected is less than or equal to the number that you want to extract that you set in your config file, we'll just return all of it. If sample by date is true, we're going to go ahead and take a random sample by date. So whatever the floor is of an equal sample across all of the dates in your system, less than or equal to the number of total samples you want to extract. Here we have a to-do that we haven't implemented yet, but if you were doing a more traditional ML classification task, you might want to sample by class. If you have confidence metrics coming out of your logs, you might want to sample by confidence metric, or sample all of the tasks below some threshold. You can implement that logic here. And if none of that is true, we'll go ahead and just take a random sample across all of your data. So that is the scrape function. And now we're going to dive into like the real flow of this code here. So the main file here, excuse me, is this monitor project with label studio.py file. At the bottom, if name equals main, so when you run this file the first time, oops, I can close that. Mostly what we're going to do here is parse out your config file. And then we're going to create this monitor object, and then we'll call monitor from the monitor object. So taking a look here at the monitor object, the init mostly just sets all of your variables to variables that are accessible from within the object. Pretty straightforward. But I'll call your attention here to line 22, which is the setup ls function. Setup ls, what it does is it connects to Label Studio using our Label Studio API. And then it pulls the labeling config either from your config.ini file or from the project you specified in your config.ini file. And then it's going to go ahead and create a new project in Label Studio. called monitoring production, called whatever we call the title. So the title is going to be model monitoring with today's date if you don't provide an existing project. If you do provide an existing project, it will be the title of the existing project, monitoring, and today's date. The idea being that way, if you've trained a model with some training data that you labeled in Label Studio, your naming convention stays the same with the addition of this monitoring and the date. Once Label Studio is set up, the next thing we do is we monitor this data. So this is really where all that flow chart comes into play that Alec was talking about before. Like we said, we're going to assume that you have your model in production. The first thing we're going to do is we're going to scrape those production logs. Scraping the production logs also, as we just talked about, will get the subset of your data for you. So now we're at the part where we need to upload that data to Label Studio so that you can go ahead and evaluate how well your model has really done. And that happens in two parts. The first thing we do is we upload the task data itself. This whole section might get a little bit confusing. There will be a blog post coming out that really articulates all of this in writing. So don't feel too bad if you need to like refer back to writing. Don't feel like you have to take a ton of notes. It will all be there for you. This task data dictionary holds the data from your labeling config that is required for the task to be set. So not your annotations, but the task data itself. In this case, it's just the question. We then upload that task to Label Studio, to the project we've just created. And then we upload from your production logs this prediction value. So what this is going to do is it's going to upload the prediction from your production model to Label Studio as a prediction. And I'll show you what that looks like in a second. But essentially what it will do is allow you to see exactly what the model has predicted in a format that it's easy to edit and understand and change. Generating this prediction value section can look a little overwhelming at first. And that's where we're going to jump over to this util.py function. I'm not going to parse through it, but what it does is it takes your labeling config, and we'll go ahead and run this here, takes the provided labeling config and spits out for you what this production value or prediction value dictionary essentially needs to look like. So you can see here that we have the model version. It just says sample model version, so we'll need to fill that in for ourselves. And then it has this result field ID we could fill in for ourselves. From name to name type will leave exactly as is. And then for value, the only thing we need to replace here is this text section. And as you can see, if we go back to our prediction value here, that's exactly what we've done. We've gone ahead and we've set our model version to the model version information we got from our logs. And we've set our text to the answer that we've gotten from our logs here. Note that is a list, as you can see in this prediction value text that we got down below. So it's a list here as well. And then finally, if you have an email set up, it will send the email. So I'm going to go ahead and show you what my Label Studio looks like right now. This is just my local instance on localhost 8080, the same way that you would regularly deploy it. You can see that I have this test labeling project from November 6th. It has no data in it, but it does have a labeling interface. We'll take a look at the code here. As you can see, it says question, and then it will provide the question, and then it will have the answer that we look at. This is the project that I've specified in my config.ini file, as the one that I want to copy for my new project. And as you can see, that is my most recent project. So now I'm going to go ahead and I'm going to run this monitor project with Label Studio as a single job. If you were running this as a cron job, it would just run the same way in your whatever cron system you're using, whether it's Dagster or Airflow or somewhere in SageMaker. You can see we've uploaded all the tasks. We've gotten an email notification, and the process has finished. And now I will pull up my email very quickly for you. And you can see, I don't know if you can see that, but you can see that I got an email at 12:25 p.m. It is now 12:26 p.m. on the East Coast. That says your project, task labeling project monitoring with today's date, has been created in your Label Studio instance. Check it out now. This way you can truly just set it and forget it. And if we go ahead and refresh my Label Studio, you can see now we have this new project right here, ready for us to go ahead and label. So if we click in, we can see that we have the question, who won the Nobel Prize in 2023? And then we have this answer. We're looking at v1.5.3, which is the version of the model that we told the prediction it was using. And this is the prediction from this is the answer from our prediction in production. If we think it's good, we can go ahead and click submit and not make any changes to it at all. If we think it needs some edits, let's say I'm just going to make a quick change here just for sort of just going to write TLDR just for, demonstration's sake. We can go ahead and submit that and it will save as a new annotation. So we can see both mine under Micaela, it says TLDR, and under the v1.5.3, it says without the TLDR. When you're done labeling all of your tasks, you can click export or export via the API. For our demonstration purposes here, I have already done that. So let me just close out some of these tabs really quick, and then I will open up this lsdata.json file. When you export as JSON from Label Studio, this is our standard JSON export format. You can see that we have the ID numbers, we have the annotations, we know who it was completed by, we have the text. You can see in this case, I wrote LOL nerd in my example. I was in a mood. And we have that for all of our samples. So the final piece of this pipeline that we do sort of manual or sort of in this package here is that evaluate against your thresholds piece. So we have this script called evaluate.py, which takes that JSON that you've exported and basically counts to see how many places you've changed the prediction. That uses this prediction changed key in the origins field. So we're going to go ahead and run this. And in this case, we changed one of the original predictions, which means we had to edit our model's output 25% of the time. In this case, we've set the threshold as 75%. So our model passed this week. If we had to change more than 75% of the examples this week, or whatever you set the threshold to, we would say the model has failed this week. And that gives you a really easy way to make that judgment call at the end about whether or not your model is ready to stay in production or whether you need to continue editing and retraining your model. Of course, you can always change this logic if you're looking at business metrics, if you're looking at maybe RAGIS metrics, if you want to also include things like confidence scores. All of that is available to you through the script. And that is basically how this package works. It seems a little more complicated than it is, but once you set it up, it should be good to go pretty much indefinitely. And that is that. So I will go ahead and throw it back to Alec and Nate so that we can open up for some questions.
Nate, we can't hear you.
Apologies. So thanks both to Micaela and Alec. That was awesome. Really appreciate you walking through this method for us. And yeah, now we've got time for some Q&A. So we'll go ahead and open that up. I just want to remind folks that there's a Q&A widget at the bottom of the screen, so you can drop your questions in there. But also, we are watching chat as well, so if you want to drop your questions into chat. But it looks like we have a couple that have already been filled out, so we'll go ahead and jump into those. I think the first question that we have is, give me a second. So how do you help engineering teams assemble evaluation sets and run evaluations without overwhelming them or slowing them down a ton?
Yeah, I could take a stab at this one, Alec, if that's cool with you. I think this package goes a long way towards helping achieve that goal because you're automating the sampling and because you're automating the monitoring piece of it. Your engineering teams will no longer have to worry about remembering to do it or taking the time to generate samples. All that logic has been written for them or is quickly editable one time for consistent monitoring. Similarly, by consistently monitoring your systems, you can look at fewer data samples each week or every couple of days or however often you set your cadence because you'll be getting a consistent eye on them. Of course, human annotation still takes time, and there's no replacement here for having somebody look at your data, but that person could also always be a subject matter expert. And of course, you'll probably want it to be an SME. So instead of having your engineers do it, although they might be the SMEs as well, I've certainly been in that position where I was both the data scientist and the SME. You could also have an SME do it. You could have a business leader do it. The beauty of doing things in Label Studio is that it is very user-friendly and very easy for even non-technical folks to get involved.
Yeah, and just one thing to add, like the one of the reasons we wanted to add flexibility into this is to like help with this problem where you can get better at this over time, right? If you say, I want to label 10,000 per week, you're going to learn pretty quickly that that's going to be too much, and that is going to be overwhelming. So you can kind of work over time to figure out what the right balance is for your team and your team's bandwidth.
Perfect. All right, awesome. Thanks for those answers, and thanks for the question. Next question I have in here is, how can an LLM be leveraged to Q&A annotation work?
That's a great question. I'm gonna actually go back to sharing my screen for just 1 second. I would say the easiest way to do that in Label Studio, oops, wrong way, is to use our Label Studio ML backend package, which you can see here on GitHub. Essentially, what you can do, if we go back to Label Studio, if you click on your settings button here, you can attach a model that you host in a Docker container or in the cloud, wherever your model is hosted, to Label Studio for the purposes of doing pre-annotation. And I'm not going to go into it right now in depth. We have a couple of YouTube videos, tutorials about it. We have a couple of blog posts about it. You can also always feel free to reach out to me directly if you would like to talk about it more. I'm always happy to chat. But essentially what this allows you to do in the ML backend package, we have a whole host of examples here for a whole host of different kinds of models that we already support out of the box. You can, of course, always build your own. They're not that difficult to build if you've hosted your own model somewhere, you have your own custom model somewhere. But essentially what this allows you to do is use a model prediction to pre-annotate your data, similar to how we're uploading these predictions here from our hosted model. And this, you could also, we have many LLM systems in here that work with that, where you could definitely build out a project that allows an LLM to sort of do some of that heavy lifting for you. Although we still recommend having a human keep an eye on that as well, because you never quite know what an LLM is going to do in production either. And then also, just as kind of a plug for our enterprise system here, we do have a feature in enterprise called prompts, which if you want to learn more about prompts, I would be happy to speak to you or point you to someone who has more information. But essentially, prompts allows you to leverage an LLM and prompt engineering in a system where you've already annotated data, which is a really great way to use an LLM to QA your existing annotations. So those would be my recommendations off the bat.
All right, perfect. Thanks for the answer and thanks for the question. And looks like we have another one here. How do you identify key stages in the workflow where human supervision is a must? And then how do you know if a particular area is impossible or near impossible to automate? So
That's a great
two-parter.
question. That's a great question too. I think as far as knowing where human in the loop is crucial, I think it really comes, there's a couple of ways you could go about this. I think it really comes down to if a human is going to have trouble doing it, a model is also going to have trouble doing it. So whether it's because it's ambiguous or because it's complicated or because there's a lot of steps, if you have humans who disagree frequently, or if a human needs a lot of training to understand how to go about a task, it's likely that the model will also need a lot of training, or not quite get it or be wrong sometimes. So those are places that are really good candidates for keeping a human in the loop. As far as knowing whether things are impossible to automate, that really comes down to testing. I'm a big proponent of always testing if I'm going to automate something. So take a data set, build out a test set, make sure the model is doing what you think it's doing when you think it's doing it. And if it works, awesome, you can automate it. And if it's not working quite right, or if it's not working as well as you want it to, maybe it's a good place to have a human in the loop, either completely a human in the loop, depending on your model's performance, or just model oversight.
Right, perfect. Yeah, thank you for that. And I mean, it looks like, you know, we've actually gotten through the questions that got asked. So we can wait a couple of seconds. If you have any other questions, feel free to drop them in the Q&A widget. Otherwise, then I think we're probably good. So we'll just last call for any questions.
I see we still have a hand up. I don't know if that's a mistake or not, but throw your questions in the chat.
Yeah, we do have a hand up, so this is your chance. All right, perfect. Well, then we'll go ahead and wrap this up. But thanks everybody for attending. Big thanks to Micaela and Alec for sharing this. And as a reminder, this was recorded, so we will be sharing a recording, and then there's also an accompanying blog post that also will walk you through these steps. And in the meantime, everybody have a great rest of the day. Thanks so much. Yeah, happy labeling.
Happy labeling.